everyone. Welcome to today's class. Today, we will learn about the specifications and main parameters of pipe fittings. Pipes and pipe fittings have a variety of specifications and types. In order to accurately represent the specified pipe fittings, in addition to the name, it is also necessary to understand the material, size model, connection method, technical parameters, and other information, etc., which is the basis for our correct selection and use of pipe fittings. First, let's understand pipe fitting specifications. Pipe fitting specifications are usually represented by nominal diameter and nominal pressure. Nominal diameter is also called nominal bore. It is a standard diameter artificially defined for the convenience of design, manufacturing, installation, and maintenance. The unit is generally millimeters. For example, common flange fittings, DN in DN50 is the code for nominal diameter, and 50 represents the nominal diameter value of the fitting. However, it should be noted that nominal diameter is not exactly the same as the actual inner or outer diameter. For seamless steel pipes, the nominal diameter is close to the inner diameter. For welded steel pipes or some fittings, the nominal diameter is neither the inner nor outer diameter, but only a specification code. Through it, the corresponding actual dimensions can be found. Next, let's talk about nominal pressure. It represents the working pressure that the fitting can withstand at a specified reference temperature, expressed as a pressure rating. The unit is generally megapascals. For example, a PN16 fitting, PN, is the code for nominal pressure, and 1.6 megapascals is the nominal pressure value of the fitting. Nominal pressure reflects the pressure that the fitting can withstand, which is closely related to the material and working temperature of the pipe. When selecting pipe fittings, it is necessary to ensure that its nominal pressure is greater than or equal to the maximum working pressure of the pipeline system during actual operation. Otherwise, it may lead to safety accidents such as fitting rupture or leakage. In countries such as the UK and the US, the nominal pressure is expressed in imperial units as class. Since the temperature benchmarks for nominal pressure and pressure ratings differ, there is no strict correspondence between the two. Typically, the relationship is as shown in the table in the PPT. Next, let's examine other key parameters of pipe fittings. First is the wall thickness, which is one of the most critical parameters. SCH, or schedule, is an important standard established by the American National Standards Institute, ANSI, to designate the wall thickness series for pipes and fittings. It is closely related to the wall thickness of pipes and fittings, which is influenced by multiple complex factors, including medium pressure, temperature, gravitational loads, and corrosion caused by the medium. The schedule standard comprehensively considers these factors and assigns a series of schedule numbers to correspond to different Wall thicknesses. ANSI B36.10 is the American standard for welded and seamless steel pipes, with wall thickness grades including Schedule 10, Schedule 20, Schedule 30, Schedule 40, Schedule 60, Schedule 80, Schedule 100, Schedule 120, Schedule 140, and Schedule 160. ANSI B36.19 is the American standard for stainless steel pipes, where Schedule 5 stainless, Schedule 10 stainless, Schedule 40 stainless, and Schedule 80 stainless are the specified wall thickness grades. Note: the S series is exclusively for stainless steel and is not used for carbon steel. In practical engineering applications, engineers select the appropriate pipe and fitting wall thickness based on specific working conditions such as medium pressure, temperature, gravitational loads, and corrosion levels by accurately referring to the schedule wall thickness standards. This ensures the construction of a safe, reliable, and economically efficient piping system. The material of pipe fittings is another critical parameter. Different materials exhibit distinct physical and chemical properties applicable to different working conditions. Common materials include metallic, for example, carbon steel, stainless steel, alloy steel, and non-metallic, for example, plastic, ceramic. Additionally, the connection dimensions of pipe fittings are essential. These dimensions must match those of the connected pipes or other fittings to ensure tight and reliable joints. Different connection methods such as welding, threaded, flanged, and socket weld connections each have their corresponding standard dimensions. Now, let's examine the specifications and parameter meanings. In pipe fitting markings, using flanges and elbows as examples. Flange marking example. WN indicates a welding neck flange. DN 50 nominal diameter of 50 mm. 150 lb pressure rating of 150 pounds. 304 material is 304 stainless steel. RF indicates that the flange type is raised face. Elbow marking example. 90 EL indicates a long radius 90 degrees elbow. 273 times 6 outer diameter of 273 mm. Wall thickness of 6 mm. 20-pound material is 20-pound carbon steel. GB/T12459 2017. Standard compliance. Through today's session, we have learned about the representation methods for pipe fitting, specifications, including nominal diameter, DN, and nominal pressure, PN, class, as well as key parameters in pipe fitting markings, such as wall thickness, schedule, and material. That concludes today's lesson. Below are some practice exercises to reinforce what we have learned.